What's going on, Principles of Engineering class? Mr. Suffren here. Today, I would like to review over activity 1.2.3, electrical circuit simulation. We demonstrated our last class meeting how to use a multimeter. I want to do a quick recap on how to use a multimeter and go over the assignment which you will be completing in the next 3 days. Okay, so let us get to it. Firstly, let's talk about how to use a multimeter. Okay, so just to recap, here is my breadboard. Okay, we went over breadboarding our last class meeting, so let's just take a really quick recap on how a breadboard is wired. A breadboard has pins which connects column rows A, B, C, and D, and there's another pin that connects F, G, H, I, and J. Okay, so notice you have these columns A through E and F through J. Then you have rows from 1 all the way to 30. Okay, and rows 1 through 30 have individual pins. So you have row 1 has all of these pins from A to E are one connection, as well as F through J, and you have 30 rows of that. Okay. Over on the side of the breadboard, you have a positive end, you have a negative end. On the left side, a positive row, as well as a negative row column that is also connected to the breadboard on the right side. These connections are all one connection. So if you see how I have my 9-volt battery right here, you can see my positive lead of my battery is connected to the positive portion of my breadboard. That means this whole row right here is live. So anything I plug in to the positive row, that's where the positive current is going to flow through, right? So if you take a look at my breadboard, let me zoom in just a little bit. So you have current going in to the positive end into my 30 ohm resistor into A19, and then it's going to go into the positive end of my LED, out the negative end, and then I have a jumper wire that is connecting that current to the negative end of my breadboard, and that is going to go into the negative portion of the battery. So this is a series circuit because there's only one path for current to travel. Okay, so here I have my multimeter. Let me turn it off. Zoom in. There we go. All right, so here's my multimeter. My multimeter has 3 ports. You have your, okay, so you have your 10 ADC, okay? You have your COM port, and you have your voltage, resistance, milliamp. So this port right here is where you're going to be testing small amounts of voltage, resistance, and current, okay? Take a look right here. Here's a disclaimer. Notice, all right, let me just back up. My black wire is going to go into my COM port. My red wire is going to go into either my V omega milliamp and or my first port. Okay, and let me explain. So relative to the third port, where's this V omega milliamp? Okay, notice that it says caution, 600 volts max fused, 200 milliamp max. 250 volts max. So there is a fuse inside your inside your multimeter. If you are unsure how much current you are measuring, it is wise to put your red port into the 10 ADC. Now look at this port. It says, hey, this is a 10 amp maxed and it's unfused. So if you're unsure that you're going to measure over 200 milliamps, put this red banana plug into the 10 ADC, and you're going to turn your multimeter on 10 amps. Now you can measure anything from under 200 milliamps all the way up to 10 amps, and you will not blow your fuse. Okay. So I recommend that if you're unsure how much current you're going to measure, put this red banana plug into the port 1, 10 ADC, measure your current, and if you see that your current is under 200 milliamps, turn it off, turn the multimeter off, and then put your red banana plug into your V omega milliamp. Then I am able to go ahead and measure my current, where you turn this dial to amps with the solid line and the 3 dots underneath the solid bar. Okay, that's how you will keep from blowing your fuse. Now, to measure voltage, instead of saying I am going to measure the voltage of this whole circuit, you are merely measuring the voltage of each component on your circuit. So I am going to measure the voltage that's coming out of my battery. All right, so here's my battery. Let me see, there it is. There's my battery. And in your case, you're going to have a power source, and this battery is going into these 2 ports right here on my breadboard. So when I measure the voltage at my battery, I should get, if it's a fully charged battery, I should get 9 volts. But if it's if it's drained a little bit, it's going to be under 9 volts, right? So you're going to check your voltage at the battery source in parallel, meaning that given that this is a series circuit, there's only one path for current to travel. Well, when you measure, let's say if I'm measuring the voltage at the resistor, now there are 2 paths for current to flow through the series circuit and through my multimeter. Therefore, I am measuring this component in parallel. Okay, so let me just give you a quick example. I'm going to turn my dial to 20. Okay, and then let me just turn on my LED. There you have it. All right. Zoom in just a little bit. There we go. All right. So notice that I am going to test or measure the current that's coming from my battery. So I'm going to put my pin right here where the battery is being connected. And notice that my multimeter or my voltmeter says 8.5 volts. So this battery is a little bit drained because this is a 9-volt battery. So I have 8.5 volts being pushed from the battery. And once that voltage is being pumped through my resistor, the voltage dropped from 8.5 volts to 9.4. 9.4 volts is going through my resistor. And then I'm going to check the voltage going through my LED, and notice that the voltage dropped even more. All right, so according to Kirchhoff's voltage law, the sum of the voltages is going to equal to the total supplied voltage. So notice that I have 8.5 volts being pushed through my battery. From my battery, I have we'll say 6.3 volts going through my resistor, and it drops. And we have 2 volts. So if you added the voltage that's going through my resistor through my LED, it will equal to the total supply voltage of 8.5. Okay, thus Kirchhoff's voltage law. Okay, now if you want to measure current, now I'm going to turn this off. If you want to measure current, you're going to, first of all, I advise you to wear your safety goggles, because I've seen, LEDs explode. All right, and you don't, and so safety is paramount. So if I want to measure voltage, I'm going to turn my dial to where it says A with the solid bar with the 3 dots under the solid bar. Now I am going to measure voltage in series, right? So in series. So what that means that current has to go through my resistor. I always advise the current going through your resistor first. Then it's going to travel through your multimeter. Then it's going to flow out of your multimeter into the LED. So with that being said, you're going to have to break your break your circuit. Okay. So that means that I'm going to take my resistor, and let's say I'm going to put that connection on A14. Okay. So I just broke the circuit. So now the current stops right here on this row. So what I'm going to do is I'm going to complete that circuit by placing my positive end on, let's say, anywhere on this row. Okay, let's say I'm going to place it right here. Somewhere you can see. All right, I'm going to place it right here. So now the current is going from my battery through my resistor into my multimeter, and the current is going out of my multimeter from the black lead, and I'm going to put this black lead on the negative end of the positive end of my LED. So I'm going to put it on anywhere on row 19, and when I do that, I complete the circuit. So my light comes back on, and notice that we have a reading on my multimeter. Okay, so we have 18 milliamps. Look like 17 milliamps. Okay, so thus I am measuring the current in series. All right, so again, make sure that your current is going through your resistor first, because if not, if it's going through your multimeter, out of your multimeter, and directly into this LED, there's more than likely your LED is going to pop, or it's going to go out, because there's too much current that's being pushed through this LED. So we need a resistor to dampen that current down. Okay, so that's how you check current. Okay, or measure current. Now to measure resistance, you make sure you take power off. Remove all power from your breadboard. I'm going to put this dial on 20 kilovolts. Kiloohms. Okay. And what I'm going to do is I'm going to go ahead and measure the resistance at each component. Okay. So I don't need any power. Make sure, disclaimer, turn the power off. Okay, when you are measuring resistance. I'm going to put my positive lead right here, put my negative lead right here, and notice I have a reading. Okay, if I want to add that third decimal, I'm going to put it right. Put this lead right here. Okay, and this is a 330 ohm resistor. Thus, I have 328. Now, this gold band on the resistor means that there's a 5% tolerance. So it can be 5% over 330 or 5% less than 330 ohms. Okay, so this falls within the tolerance. Okay, so if I want to get the resistance at the LED, we do the same. Oops. Okay. There we go. So that's how you check resistance. So we've checked resistance, we checked voltage, and we've checked current. All right. Now, last thing I want to do, in your activity, you're going to be building your breadboards, right? This is a simulation, so you can do this at home. Okay. I want you to practice. Wiring your breadboards while you're in class. Okay, because there's going to be an activity on this later on. So while you're building your circuits in Tinkercad, right? If your breadboard or your circuit do not work on Tinkercad, do not do it physically on your breadboard. If it works in Tinkercad, build it physically. Okay, so it's going to ask you to add a switch, and we don't physically have a switch, but you do have these little push buttons in your toolbox. Okay, and so what I'm going to do is I'm going to build a circuit. What I'm going to do is I'm going to put and make sure that you strip a wire. Take your red wire, strip both ends, okay, and then you're going to put it into your breadboard, and the other end of your wire, you're going to clip it with your power supply, okay? And we covered this our last class meeting. So we're going to put our positive end right here, and we're going to let's throw a jumper wire, let's say from this positive end to, let's say, row 17, okay? And then we're going to, let me move this, we're going to add our switch. Okay. Now, see if you can see that better. You're going to add your switch, and I'm going to add this switch, let's say, and I'm going to add my jumper wire now to row 16. Now notice that we have current going from the battery to row 16 to this leg of my button switch. Okay. Now the current is going to run diagonally from this leg to this leg. So what I'm going to do is I'm going to put my resistor on row 14. Okay, put it on row 14, and I'm going to have my, let's say I'm going to have my LED. I bent it a little bit, so I'm going to have it, okay, bend it this way. There we go. So I have my positive longer leg right here, my shorter end of my LED leg, right on, let's say, let me just pick a row on row 22. So I'm going to, let me move this jumper wire. I'm going to move this resistor to go to my positive end of my LED. Sorry if you cannot see. There we go. So we have current going from this jumper wire to row 16 to this leg right here. Current is going to go from this leg to this leg. And I have my resistor on row 14. There you go, on row 14. And current is going to go from my resistor to row 19, which the longer leg of my LED is going to be on row 19. And it's going to jump from row 19 to row 22. And now I'm going to put my jumper wire from row 22 to the negative end of my breadboard. And that's where I'm going to have my negative side of my battery. Okay. So now, let me zoom out. Now, when I add power, okay, notice that it doesn't come on because the circuit is broken. Now, when I press the button, the circuit is closed. Okay. So when you are building these circuits, make sure you understand where the current is flowing. Okay. So now you understand how a breadboard is wired. Based on how you understanding the connections of a breadboard, just understand how your current is flowing. Is it flowing in series or is it flowing in parallel? Okay, pretty cool, huh? Okay. So with that being said, let me switch over to the activity and what you're going to do today. Let me share my screen. Okay, there we have it. So you should be in day 2, item 2, activity 1, 2, 3, simulation. When you click on simulation, you need to go to complete activity 1, 2, 3 electrical circuits. Once you click on this link, it's going to take you here to activity 1, 2, 3 simulation. You are responsible for reading the literature. Okay. Thus far, we have reviewed number 1, introduction to electricity. By now, everyone should understand how to solve for the resistance total for a series and parallel circuit. You should understand how to calculate the current that's flowing through each component in a series and a parallel circuit. You should understand how to calculate the voltage that's going throughout a series and a parallel circuit. And you should understand how to verify Kirchhoff's voltage and current law. Okay. So you should understand that. If you do not, please review number 1. Step 1. In your engineering notebook, as well as a Google slide, you're going to add all of your answers to this simulation on your engineering notebook, and you're going to do a snippet of that and put it in a Google slide. Okay, this table right here shows you the different components in Tinkercad that you could, no pun intended, tinker with. All right, and we'll take a look at that briefly. You should understand these symbols of a circuit. This is your multimeter. It covers Ohm's law. Okay, then it gives you some practice calculations. Okay, in your principles in your engineering notebook, complete steps 2 through 4. Okay, then it tells you to go to Tinkercad. Click on this link, it will take you to Tinkercad. Okay, what you need to do is click on Tinkercad, sign in. When you sign in to Tinkercad, you're going to click on new, and it's going to give you a new file to build a circuit. Okay, I'm going to tinker this right here. Notice how my circuit files are named. Activity 1, 2, 3, step 11. So when I go to step 11, take a look at step 10. It's a nice interactive video. All right, step 11 says, hey, add a multimeter component to the workspace and connect the multimeter to the battery terminals. Make sure the multimeter is set to voltage mode. Okay, so when I go to Tinkercad, I can take this, I can click on this multimeter and set it to either voltage, amperage, or resistance. That's what it's saying to do. Step B, select start simulation and note the voltage. So what you're going to do is hook this voltmeter to this battery. Make sure you connect the wires. Okay. When you connect the wires, I'm going to select this wire and I'm going to change it to red. When you start the simulation, what happens? Your voltmeter is going to give you a reading of 9 volts because this is a brand new battery and it's pushing out 9 volts of current. Okay? Does that make sense? In your activity, it's going to ask stop the simulation and then switch to terminals. When you start the simulation again, what do you notice? You're going to answer those questions in complete sentences, okay? You can also check your response, right? And it gives you the response. So this is a give me right here, all right? Please, you can feel free to work in groups, okay? Feel free to work in groups. You're going to do a snippet. So what I'm going to do is go to this magnifying glass right here. I don't know if you see it, and you're going to type snip, and it's going to give you your snipping tool, S-N-I. All right, so it's going to give you your snipping tool, in which you're about to see very shortly. I don't know if you see that, but you're going to take a snapshot of your Tinkercad of step 11 and throw it on a Google slide with your reflection question. Reflection questions must be done independently, okay? Work as a group. The only thing I want you to do is complete all of this. It's very lengthy, and I want you to learn, okay? So take your time. Don't approach this as in, I need to hurry up and get finished. There is a timestamp. You have 3 days. So make sure you plan your time. But most of all, I want you to learn from this because this is going to be on your midterm exam, okay? We'll have quick check assessments where you will need to understand, what we went over with regards to circuitry, okay? So step 12, it says, just go ahead and just analyze this parallel circuit. I'm sorry, this is a series circuit, all right? But there's a voltmeter right here measuring this circuit or this LED in parallel, okay? Use a 9-volt battery to power your supply, add your light bulb, and it says check your work. So what you're going to do, you're going to wire this just like this. Let me go to my Tinkercad to see if I've actually done this. I'm sure I have. Let's see. Circuits. I'm sure, there it is, right here. Let me tinker this. Okay. Again, you're going to build your circuit. Once you build your circuit, I would like for you to build your build this on your breadboard. Okay. Notice you have a switch. Notice that you have power going from the positive lead of the battery into your switch, out of your switch to the LED, and back to the battery. You have the multimeter measuring the current at the LED, and it's measuring it in parallel. Okay, just what we went over physically on my breadboard. When I start the simulation, when I turn the when I start the simulation, notice I have 8.73 volts going through this LED. Okay, when I switch this off, it's going to ask you another question. Okay, so basically what I want you to do is go through this, answer the questions, understand the concepts. Okay, understand the concepts. Notice I have some answers right here. Okay, but understand why is 8.73 volts going through, being measured on my voltmeter. Understand what's happening. Okay, if it asks you a reflection question of, was the voltage across the battery what you expected? Answer that in a complete sentence. What could you account for in observed differences? Okay. Converse with your table partner. Understand what the question is asking and reflect on it. Okay. Reflect on it. Now, everybody should answer your reflection questions independently. So when I'm checking over this, I shouldn't see the same word for word answers. Okay. Answer all the questions, pace out this lesson. This will be a perform grade since it's pretty lengthy. Okay. I think that's about it. If you have any questions, feel free to message me. But I will see everybody, since I'm not in the classroom today, I will see everybody on Monday. Okay, so be ready. You will see a quick check assessment on what we've done in activity 1.2.4. Okay, have a great day. Peace.